Hello everyone, my name's Tony Gleeson. I'm the Chief Executive of ERA, and more importantly, I'm the Chair of the Innovation Hub for Affordable Heating and Cooling projects or series of projects. So welcome here today. And before we begin, I'd also like to particularly acknowledge the people on the lands on which we meet through not only here in Melbourne today, but throughout Australia. And in particular, I want to pay my respects to those elders, both past, present and emerging. And I want to celebrate the diversity within Australia, but more importantly, the diversity within the Aboriginal people and what they bring. I want to acknowledge their respect to the country, what they protected and cared for over many thousands of years before current settlement. And I also want to respect and acknowledge their connection to both land, water and community. I'd also like to follow that on and thank for the support of the government, Australian government, particularly the Australian Renewable Energy Agency, ARENA, for their investment in this project. This overall project is an $18 million investment into the concept of affordable heating and cooling, but more importantly, it's an investment in driving to Australia to a net zero future. And we appreciate their support and contribution in this space. Particularly today, we're going to be hearing about the data clearinghouse. This data clearinghouse or project has certainly been responsible, being led by CSIRO with Stephen White. We've had contribution through the New South Wales Government Education Infrastructure Fund, and also through Deb Nola and the participation of Switch Automation. The other key participants have been Building Evolved. Particularly this project, I think, is very interesting because it's leading to, I think, really pulling a lot of the threads that are out there around buildings and the design of buildings and bringing it all together. Of course, throughout, apart from this webinar, there's also a lot more information on the Innovation Hub website, where you can see past webinars, but more importantly, get an update on each of the milestones as we progress through this project. So I'd like to hand you over to Stephen White from CSIRO, who will now lead us through the presentation. Thank you, Stephen.
Welcome everybody. This is a presentation specifically on one part of the Affordable Heating and Cooling Innovation Hub, which is the Data Clearinghouse activity. And there are a series of projects in that, and you'll get an update of a couple of those. But I just wanted to sort of start off, and I know some people will have been on the June Knowledge Sharing Summit that we had, but just a couple of slides just to introduce this sort of concept of the Data Clearinghouse, and then we'll hand over to the speakers. And really, we've got to say, well, what is it the problem that we're trying to address with this particular activity? I've got my own barriers slide, but just recently I came across this one from the American Council for Energy Efficient Economy, and I thought just like the way it sort of pictorially represented that. So the barriers to smart buildings, and particularly grid-enabled buildings for a clean, affordable and reliable grid, one of the key barriers is interoperability, the ability of devices to speak to each other and for software to speak to each other and for solutions to be done in a scalable, machine-readable way. So we're definitely approaching that as an issue that we're trying to deal with in the Data Clearinghouse through standardization. Cybersecurity is a core issue which affects everything we do, and really, there is no substitute for best practice in cybersecurity, but what we think there is potential to create efficiencies here by dealing with cybersecurity once through a data platform, and then to be able to share data from there, and in that way minimize the number of times that people have to deal with these issues. And then the workforce, clearly there are a number of barriers around the workforce, supply chain split incentives, skills barriers as we come across emerging technologies of the Internet of Things, and really the opportunity to centralise some of those skills so that we can maximise the use of what skills we have is something that we would like to address. So the general concept of the data clearinghouse to address those barriers is to do something which is, you know, reasonably perhaps revolutionary in our industry, which is to abstract out the data part of it that's going into the building and collecting the data in one place, and then federating it with other data sources, data from the web, data from Internet of Things, sensors and devices, bring it to the one place, and then use that to enable data-driven services. So I've kind of taken a bit of an analogy there with our electricity system, where there's the poles and wires part of it, which is the common infrastructure that we all need to work off. And in this case, the poles and wires, I'm saying, is the data for our smart buildings. But then there's the retail services, which is where we take the data and make it available in different what we would call applications. So the task of the data clearinghouse as a platform is to get the data out of the building, federate it with other data sources, put it into interoperable, standard, structured formats so that we can have an entire ecosystem of analytics providers providing software as a service solutions. And in some ways, I don't know, for the policy wonks amongst you, this would be a little bit like a consumer data rights type mechanism, but specially built for the commercial buildings. And so we hope to host a wide range of data-driven services or applications. So that's the kind of underpinning sort of philosophy and sort of infrastructure we're creating in this project. And then we layer on top of that different buildings and different applications that run as projects in the data clearinghouse. So that's just by way of introduction, repeating what was said pretty much in June. And now we've got some presentations. So Deb Nola of Switch Automation was the lead on the Data Clearinghouse 2 project. And so she'll report in on that and give a bit of a philosophy of just where this smart buildings is coming from as well. Mark Goldsworthy has built a measurement and verification app, which is being hosted on the Data Clearinghouse. And there's some really fun learnings we've got from that as we look at the impact of COVID on buildings. It's just an example of what you can do when you've got the data. New South Wales Schools is another project, which is photovoltaic air conditioning integration. We've had a late withdrawal there, so I'll be presenting that presentation on the schools application, and then I'll just give a sort of a rundown at the end in terms of where we're going with all of this and what to expect. And then there's the chance, obviously, for everyone to ask questions of the speakers. So I think that's me. Without further ado, I'll hand over to Deb Nola.
Hi everyone, I'm Deb Nola, CEO of Switch Automation, and I'm going to assume that you can see my screen and not ask for confirmation. I'm sure somebody will tell me if you can't. So I'm really excited and pumped actually about smart buildings and the industry and the impending growth, and I love the opportunity to talk about where this is all going, but particularly for audiences like ERA, who are basically right in the nexus of this, what I would call a perfect storm. And you know, when you're a startup founder, everyone tells you it's all about timing, and smart buildings is, you know, absolutely all about timing. So this is a huge growth market, and we've been waiting for the last 20 years. This is not a technology problem, why smart buildings has not taken off. It's really a market issue. And it's really been waiting for the right factors to kind of kick the can down the road and get the growth happening. And I think that there's a number of mega trends behind this space right now. So the first one is digitisation. So digitisation was happening anyway at the enterprise level. What you saw for the last 20 years is consumers have adopted technology and become digital. We no longer have Refidexes in our cars. We don't even have TomToms in our cars anymore. We just basically run everything off our mobile device. Nobody carries around an address book. We adopted technology basically because our friends and family were doing it, and we watched other people do it, and we just self-adopted. What happened in enterprise, because they have so many hurdles and obstacles to get over around data and cybersecurity, etc., and budgets, is the enterprises are about 20 years behind their consumer, and so there's this catch-up happening now, and no CEO wants to be the next Kodak, and so there's a real kind of acceleration. And then add to that already existing environment, COVID, and what you saw this year was a huge acceleration of digitisation of the enterprise. The second trend is the climate emergency, which is almost, well, I call it a climate crisis now. We've moved well beyond the fact where this was climate change. It was well recognised in the 80s. The insurance companies were already factoring in climate change. It was only in the 90s when the lobby groups got themselves organised that there became, an obstruction to adopting strategies to address climate change. And because now we've left it till 2020, it's actually extremely urgent now that we address that in the next few years. The third mega trend is regulation. So you're seeing cities like New York, all over the US, Melbourne, where cities have already identified that they don't have enough energy for the next 50 years if the growth continues into the cities the way it has done for the last decade or so. And no politician wants to put their name on a new power station. And the studies have shown us that if we are just more careful with the energy that we already have, we can actually get the next 50 years of energy from what we already have. So the cities are becoming very well organised. New York City's introduced Local Law 97, which is getting the incentives right, because up until now the incentives have been wrong. If the landlord spends the money, the tenant gets the benefit, therefore the landlord won't spend the money. So Local Law 97 says you must be 40% towards carbon neutral by 2030 and 80% there by 2050, but the fines actually start in 2024. The fourth megatrend, which is huge, is the amount of money that is coming into our economies for the post-COVID stimulus. So any of you that are following the Energy Efficiency Council newsletter will see that South Australia government has earmarked 60 million to go into upgrading government buildings. Last week, Victoria announced 59 million going into greening government buildings. It's the Joe Biden plan to address climate change is $2 trillion if he can get that through, and a lot of that money is coming into upgrading of buildings and the infrastructure around buildings, if you think about things like schools. So all of those mega trends are huge, and then you add to that the generational change. So if you look at the way buildings have been managed for the last 20 or 30 years, it's largely the old white guard. So it's older white male people who are retiring. They're taking with them skills out of the workforce. So we have a retiring knowledge base leaving, but at the same time we've got an incoming generation of people who are just not going to be as accepting of running buildings in the manual way that we have done for the last decade or so. So all of these things are contributing to what I would call a perfect storm, where you're going to see this vast acceleration of moving towards smarter, connected digital buildings. So we tend to call that digital engineering, but there's some case studies that I can present here where companies like Oxford Properties, who are digitising their FM team, they recognise that they've got 200 buildings, a facilities manager in every building. Those people are retiring, they're taking skills with them. Their view is that those buildings will be managed centrally using data analytics and a central smart buildings team rather than distributing that across each building. They have 17 buildings already in their national programs, and they're saving more than $1 million a year. Empire State Building started a decade ago, did some highly innovative things. They replaced all their lighting with LED. They changed all of their elevators to use regenerative braking. So their 73 elevators actually produce energy rather than use energy. And they also replaced all the windows to have more better thermal efficiency. So they actually saved $4 million a year and got a 40% saving, and they're now focused on the next frontier, which is, you know, health and well-being and indoor air quality, and doing some really innovative things around that. They are also the first portfolio globally to be well certified. And then here in Australia, we're seeing AMP Capital moving towards data-driven HVAC maintenance, which is highly innovative, and, you know, it takes some new blood and new way of thinking. But, you know, they basically hired somebody to head up this program. The management of AMP Capital gave him the mandate to be able to get the job done, and he's a guy with a lot of courage and a lot of confidence in how technology can solve for them. So they're moving towards a data-driven maintenance regime rather than being reactive or cyclical based on the maintenance programs. So they've got 45 buildings digital ready, and they'll be starting that program on 1st of January. And you would have already seen some of their projects announced in the newspapers. They're doing some AI with BrainBox, for example. So that kind of brings us to why I'm excited about the data clearinghouse. So this project has 3 phases. The previous phase was for us to build an open infrastructure that allowed any building to be able to push their data into the data clearinghouse, and then for any applications or consumers of data to be able to get that data out using APIs. So we've done that, and now we're proving that with 3 of the CSIRO buildings using the data clearinghouse and putting fault detection on and building a business case for why this is so important. And then the future phase of this project, provided it gets funding, is to build a complete open marketplace where the entire industry can build applications, and you could build up a whole ecosystem of people that are not only contributing that data but also consuming that data for, you know, third-party applications, etc. So we're tremendously excited and honoured to be part of this project. I think it's really a way of us showcasing Australian tech, Australian innovation, but also Australian policy. This is a project that has the ability or the potential to go global. Governments all around the world are looking for this type of initiative. Buildings use 30% of the world's energy. Half of that is in heating and cooling, and at least half of that can be saved with no impact whatsoever on comfort or operations. We know that from our experience in the data that we've already used. So we are, you know, excited to be part of this, and really grateful, actually. So just to give you a quick recap on what those 3 buildings did, we put 3 campuses in, 21,000 square metres. We've only been running this since May, and we've already identified $30,000 worth of savings. We would anticipate getting at least 10 to 15% energy savings out of those buildings, and some events that we've identified. And then just one other outcome that comes out of digitisation is that whole potential and opportunity to introduce diversity. So our company is more than 40% women. It's more than 40% of non-white, and in fact our white male statistic is less than 40%. So I think it's a great opportunity for us to not only positively impact the planet, but just to create a whole generation of really diverse and digital jobs. And so that's what I am really passionate about. That's it, and I'll wait for questions at the end. I think we're doing questions at the end, right?
Yep, that's correct.
Thanks.
Thanks so much, Deb. That's so exciting. Tight for time, so I'll pass straight to Mark Goldsworthy on the measurement and verification app.
My name is Mark Goldsworthy. I'm a researcher at CSIRO. My presentation today is talking about the development of an M&V, a measurement and verification application on the DCH platform, and using that application to estimate the energy use impact of the COVID shutdown at one of our CSIRO sites. So, touch on motivation, why we're looking at M&V and what is M&V, the DCH tool that we've developed and how it's been validated, and then the results of the analysis of the Newcastle site. So motivation, I think, is pretty clear. So obviously building energy efficiency is a key area for reducing operational costs and emissions, but accurate quantification of savings is really important, both to justify any capital outlay, but also just to understand what's happening with any of the measures that have been introduced. So high resolution data makes it easier to quantify those savings, but it's still a time-consuming process to take the data and manually clean it and process it. So that's where the automated applications come in. So M&V is really an ideal application to demonstrate what the DCH platform can do. So M&V is certainly not a new concept. So there's an entire M&V industry. There's standards, ASHRAE standards, international standards. But there's been quite a few recent developments, basically stemming from the increased availability of really high resolution metering data and sub-metering data as well. So the purpose of M&V is to verify energy efficiency upgrades or control system changes, or even to identify faults in the building operation. So there's different techniques. So you can look at the whole building. You can try and isolate one particular area of the building where the change has been made. You can do simulations as well, and it's also can be used for reporting. So you can look at how the energy use behaviour of a building or a site is changing from month to month, and get a good feel for what's happening. So the DCH M&V tool, so it uses electricity metering data. It could be half-hourly data, or it could be finer grained than that. Could be hourly, but generally high-resolution data. It's got a bunch of data cleaning functions, so no data is perfect. It always has missing amounts or anomalies where sensors have just returned an incorrect value. So there's a lot of cleaning, interpolation, synchronization type functions. Then the core algorithm is what's called a weighted piecewise multilinear regression. And then the output is estimates of energy savings from the building and confidence bounds around those savings. And if you've got tariff information, obviously cost savings as well. So, of course, have to validate any method. So the EVO, the Efficiency Evaluation Organisation, is an international group focused on improving energy efficiency. So they have an online portal of data from 360 or so buildings from the US, 1 year worth of data. So anyone can go on and download this data, run your model, and generate predictions for the following year. And they're blind predictions, so the person running the analysis doesn't know what the answer is. And then, so you run your model, you do your predictions, and then you upload those to the portal, and it tells you how well you've done. So when we did that for the DCH tool, essentially we got pretty good performance. So the dot there on this plot is showing how the model is done with two error metrics. So basically, the one on the vertical axis we want to be 0, so it's the net mean bias error. So you don't want the model under or over predicting, so you want it to be 0. And the horizontal axis is the root mean square error, so you want that to be small. So this green dot is the DCH tool, so it's doing about as well as some of the best tools out there internationally. And there are a lot of different approaches to doing M&V as well. So there's machine learning tools, there's neural nets, and so on. So now that we can be reasonably confident the tool is working, we did some analysis of one of our CSIRO here. This is the one at Newcastle. It's a fairly large site. There's a 3-story office building, a 2-story lab building, a large process bay, and lots of other outbuildings. About 200 kilowatts of PV, and usually there's about 120 staff on site. But during the shutdown, or the partial shutdown for COVID, there was about a third of that occupancy. So we wanted to look at, what is the energy change before and after. So the data used was the net metering and the PV generation data, and ambient temperature data for the site from the Bureau of Meteorology. And that was half-hourly data. So the baseline period was October to February 2020. So that's the period that we use to train the model. So that's the period where we say we're wanting to compare, that we're saying is the baseline behavior of the building. And then the analysis period was April to September. So it's covering the majority of the reduction in occupancy. So over the analysis period, the data completeness was about 93%. So you can see, I'm not sure if you can see my cursor, but on the top figure at the right, there's a few gaps in that data. So that's the processed data. So the model needs to be able to account for that and not just estimate reduced energy use because there's no data there. So we trained the model on the baseline period and then check how well that model is doing. And that's what the plot in the bottom right is showing. So it's showing essentially the error in the daily average error in the model. And then the red line on the bottom right plot is that error in the analysis period. And you can see there's a clear shift in the center line of the blue and the red line. So that's showing that there clearly is a difference in energy use. So we can look at that difference on a month-to-month basis. So the model is saying that the site consumption of energy went down between 14 and 17% overall. So that's weather normalized, and during occupied times that reduction is a bit higher, as you might expect. And then we can also calculate the cost saving, which is about $16,000 over those months. So we can also get some other insights out of the analysis. So we can pull up how energy use or consumption has changed over compared to temperature, and look at those trends. And we can also look at how energy use has changed over the hour of the day. So that's what these two plots on the right are showing. So clearly the solid line here is the actual over the analysis period, and then the blue dashed line is what you would expect if the building had continued to operate in the same way. So there's quite a big reduction there, particularly as it gets warmer. And there's a much smaller reduction in the base load, so as you might expect. So the base load of the building is fairly independent of the number of people there during work hours. So the other thing the model tells us is it infers the occupancy of the site. So not the number of people occupying the site, but just whether the site is sort of active or not. And that inferred occupancy pattern is close to what we see the actual pattern is. So future work, so we really want to be able to deploy this tool not just over one site, but over hundreds or thousands of sites with a click of a button. So the building ontology that's within DCH will allow us to do this. So the ontology essentially categorizes all of the sensors and things so that we don't have to automatically connect up the data streams to the application. It all happens automatically. And to develop a user-facing front end so that can do reporting and automated alerting and other things like greenhouse gas evaluation and cross-validation of the models. Thank you.
Cool. Thanks so much, Mark, and good to see the M&V app working so well. That kind of pretty core to the energy efficiency story to be able to get that to work. All right, we'll shift on to the third presentation. And this one I'm doing a fill-in for the New South Wales schools project. So you'd ask, why would schools be interested in the data clearinghouse? And there's a bunch of reasons that we could hypothesize here. One is the consolidation of data in one place and making it visible to authorized people. And so if that data is consolidated in one place, then air conditioners would be visible from people in central office. And so that's an important thing to happen for reporting purposes, but also for the awareness of what's going on in the field. So when storms come across and if there's any hail and stuff, is the PV still working? It'd be something that you'd want to have some sort of recognition of. And that was a kind of a thing when we talked to one of the other school departments was seen to be quite an important factor. Also, from a bill savings point of view, the ability to take the data and use that to be able to manage the operation of the air conditioning and to provide flexible demand. Flexible demand could be used in many ways. It could be used in operation to minimize the cost of the electricity that you purchase, and that is to make sure that you consume more of the PV as it's produced on site, so self-consumption, as opposed to exporting it where it gets a lower value. But also the ability to minimize peak demand is important. And I saw again that there was an article just the other day now where air conditioners were not being able to be turned on in schools due to the fact that they were exceeding the capacity of the network in those areas. So it has kind of operational, bill savings, reporting, facilities management. All of these things can be supported by getting the data out of the school and being able to utilize it from the cloud. And in the context of what Mark was just talking about in terms of measurement and verification apps, the ability to have some sort of independent measurement and verification so that when claims are made as to savings, there's some sort of independent verification is clearly something that was attractive to schools as well. So in the New South Wales Schools project, DCH 6, it's a pilot in 3 schools, Singleton, Jamison and Nimbin there, where batteries are being inserted in the schools. Some of the schools have got some existing PV, but the PV is being added to as well. And so you can see the extent of the implementation of batteries and PV. But then also adding to that the ability to manage the air conditioning demand to give a package of flexible demand and integration of PV with demand. So the work that is going to happen inside that project is doing some of the financial modelling of, what's the optimum amount of batteries and PV relative to the amount of flexible load from air conditioning. And also to demonstrate the efficacy, I guess, of the data clearinghouse as a tool for capturing the data and consolidating that data and making it available to the various stakeholders in Schools New South Wales. And ultimately, the aim is to manage batteries and flexible air conditioning loads. So just giving you some of the results, preliminary results, we're only sort of 6 months into the project, but some of the preliminary financial modelling there, just comparing different scenarios of PV, batteries and air conditioning flexible demand. And so you can see 2 schools there. One school has got a relatively low tariff, another one's got a relatively high tariff, and then applying solar PV, and then applying solar PV with adding of batteries, but having a control scheme on the batteries for 3 different scenarios. One of them to maximize usage of solar electricity on site, that's maximize self-consumption. Another one to minimize peak demand, so more of a network perspective. And then another control strategy being arbitrage, that is charging up your batteries when electricity is cheap and dispatching from the batteries when the electricity is expensive. So that's 2A, B and C, the 3 control strategies with solar PV and batteries. Then CCP3 implements the air conditioning controls as well. CCP4 is the PV, the batteries and the air conditioning. In each of the cases, the air conditioning controls seems to be, from this modelling, to be the most attractive solution. And you can see various levels, and the axis there is net present value, and I believe that's over a 10-year period. In this particular case, it was 100 kilowatts of PV and 100 kilowatt hours of batteries was the assumed sizing there. And there's additional modelling done with the SAM tool, which some of you may well be aware of, which is really looking at then what would be the right size for a given school. So another component of the work, so that was the financial work so far, and another part of the work is the actual piloting. We don't have the batteries installed yet. I believe that they're going in December and should be operational in the new year. But given some of the delays in getting that going, we've actually built a demonstrator in Buildings Evolved's office. That's the controls contractor there, and trying to replicate the school's application so that we're ready to hit the ground running once the PV and batteries are installed. So the system that's been built as our demonstrator and tested there has got the EasyIO programmable logic controller there, and all the data from the solar PV, the air conditioning and the electricity meters, independent sensors and even manual controls all going into that PLC. That's on site. And then on site, there is also an edge server there, which is running Node-RED. And this is sort of the way in which we're sort of changing out of the sort of SCADA type environment and putting it, then transferring it into an IT environment. So the Node-RED is a flow programming thing that takes Modbus and converts to MQTT for dispatch then to the cloud, and that allows sort of high frequency near real-time sampling. So that data then goes out to the cloud where it's picked up in the data clearinghouse, and then the data can be dispatched to whoever has got applications that schools want, and data can be trended. It's a time series database for doing that. So that system is all working, data is going into the data clearinghouse, and everything is operational. So we're just waiting now for the site to be ready for implementation. So next steps, complete the installation of PV batteries and get that control system into the schools, perform the baseline modelling, and then start applying the PV demand response control strategies. So the project is going well, and then the final presentation now is just to give you an update on where things are at with the data clearinghouse. There's kind of data clearinghouse, the software, but there's also data clearinghouse, the concept of some ongoing entity that will actually operate this in a financially self-sustaining way. And so a little bit of an update there on how we're progressing. In terms of what's happening in the Affordable Heating and Cooling Innovation Hub project, the general plan there through the milestones is that we've been testing different software platforms. So you heard from Deb Nola and the Switch platform. There's also been a Data61 platform, Synapse platform that's being tested. And we've also been out comparing other platforms, more desktop study on other platforms to try and identify what would be the best software platform that could that the data clearinghouse could use going forward. We haven't come to the final landing there, but we're getting close now, having had a lot of consultation with international players and local players, and looking at what we've been doing in the DCH 1 and 2 projects. We've done some assessment of just how much demand resource there is available and how significant that is in the electricity industry. We presented that work at the June summit, and there's been some additional work there in response to comments that we got back from that. And now really it's just about sort of launching the data clearinghouse as a platform, and I'll talk about that in a moment, and just building up the ecosystem in terms of buildings that are using the data clearinghouse and software services that could be chosen and utilized on the platform. And so we got sort of targets, KPIs in terms of numbers of buildings and number of apps being hosted on the platform. So just to give you a bit of a flavour then of how that's working. So as I mentioned, we've got the Data Clearinghouse 1 and 2 that's investigating two sort of software platforms that could perform the base of it. Got some additional work around ontologies in a proposal that has not yet got approval for getting started, but would certainly add to that, and particularly in terms of adding to the facilities management component of the Data Clearinghouse. We've got a project, Data Clearinghouse 3, which is really focusing on air conditioning, LoRaWAN operated air conditioning controls in a retirement living application. And so that's a company with a product that they'd like to integrate as a data source into the Data Clearinghouse. And then we've got a bunch of app developments that are looking to get hosted on the data clearinghouse. So we talked about DCH 6, that's the schools one there, and ultimately that would be a flexible demand app that sits on the data clearinghouse. And similarly, there would be a flexible demand app from DCH3, and then there's another bunch of projects that are waiting, hopefully, to get approved to then continue to develop additional apps. The focus, this is ARENA funded, that is, and ARENA's mandate is enabling renewables, and so there is a focus on that sort of flexible demand as a way of facilitating increased amount of renewables. But apps from other places and other purposes can all be added onto the data clearinghouse, not necessarily funded by iHub, but broadly as we go into a self-sustaining mode. And of course, we just want a large number of different building typologies, commercial buildings, and schools, hospitals, hotels. We'd love to get a diversity of building types and different climate zones being represented there. So at the moment, we've got more than 25 buildings that have been pledged. Not all those have been approved yet, but they've been pledged as projects. And so even without launching, we're getting a good stream of buildings that look like coming onto the platform as we go over the next year. We've done a lot of industry stakeholder work, talking to different interested parties to see sort of how that fits. And really, it would be fair to say that we got a very warm reception from all parties. The smart buildings industry at the moment, it would be fair to say, is a relatively small industry. And so anything that we can do to remove barriers to grow the pie, as opposed to compete with the pie, that grow the pie is something that is potentially of interest and benefit to all stakeholders. Our surveys suggested that these sorts of issues that we talked about and focused on as to why we exist around interoperability and stuff are still barriers. Everyone said that. We were told, hey guys, there's no shortage of data platforms out there, and they come from different origins, some from the IT world, some from the design, construct, BIM kind of worlds, etc. And so but it would be fair to say that no platform at this point in time has necessarily got a high degree of traction, and something that would be operated on a not-for-profit sort of by the industry, for the industry type mode is something that is deemed attractive. Wide range of digital awareness sort of came up. Some people are sort of, and Deb mentioned some companies that have sort of launched into this world and are sort of getting on their tracks. Others are still wondering what could be the value proposition. And that was probably a flavour that came through a lot of our consultation is, we don't mind the costs so much as long as you can show us how this actually gives us value properly. And it would be fair, it seemed like no one had necessarily nailed that value proposition around any one particular killer app, if you like. And so part of the value proposition we're saying is that we have the ability to host a wide range of applications, and therefore you gather and consolidate the data once, and then you're able to get a whole range of different value propositions, from fault detection through to energy optimization, through to facilities management, etc. Building owners, definitely non-proprietary governance was something that was attractive to them. And you can read these points as well as I can, I guess. And cybersecurity was definitely an issue that that is understandable and is kind of a given, a license to operate issue. So next steps for us is really planning for launch, and so it looks a lot like sort of a business planning exercise, sorting out our governance model, and our plan is not-for-profit, member-based organisation. We need to find some sort of pricing structure that provides financial self-sufficiency, so that it's not sort of leaning on anyone else, and we need to continue to develop software or make allowance for that and get the message out to the industry. So I've got a little 2-minute video. It's just almost a recap, I guess, and then we can go into the Q&A. So yeah, please start putting your questions into the Q&A section there. And this is just a 2-minute summary of what we believe the data clearinghouse is. And I'm just going to stop sharing and just reshare, just so that I can make sure that that I've done it in the right way. Okay, yep.
The iHub Data Clearinghouse is a real-time cloud-based data platform for management and reuse of data across multiple services that enables more efficient building operations and enhanced occupant comfort in new and existing buildings. The Data Clearinghouse, or DCH, has been developed to benefit both building owners and service providers. The platform enables building owners to collate data from disparate sources in one location, retain ownership of data irrespective of service providers, reduce data transfer and management costs, and provide portfolio-level insights. And it enables service providers to access building data without data collection responsibilities, access large number of building owners on the platform, deliver services applications for multiple buildings without labour-intensive building-specific customization. To achieve this, the DCH uses standardized contextual data structure called a building data model that enhances the discoverability of data by capturing the location and relationships of sensors, equipment, and control systems. In addition, the DCH has a secure near real-time data ingestion and federation capability from existing building systems, low-cost, easily deployable Internet of Things sensors, and third-party cloud data sources such as weather forecasts. The DCH applications utilize the sensor and building model information to provide richer data analytics, more accurate fault detection, enhanced occupancy comfort controls, and other innovative solutions. The DCH platform integrates private data sources securely, providing tools for building owners and their delegates to manage data access for applications. The DCH supports interoperability and open data standards whilst maintaining high standards of data security and privacy. Under the leadership of the Australian Institute of Refrigeration, Air Conditioning and Heating and the CSIRO, the Data Clearinghouse platform is an open and secure system run by the industry for the industry and will provide a new accessible arena for innovation and competition.
Well, do you feel pumped? Hope the video came through well. Okay, well, let's open up for Q&A. So the question, what is the minimum building data required for potential building owners to join, e.g. 30-minute site electricity data, more, etc.? Yeah, that's a good question. And it kind of almost goes to the heart of how much is the right amount of data, and sort of obviously different building types that have got more or less data, and what's cost effective and things like that. I don't know, perhaps I could pass it to you, Deb, and not just for the data clearinghouse, but for switch automation platform. I mean, at what point would you consider a building an appropriate building, and how much data is the right amount of data?
Good question. So on a single building, you're not going to get a lot of value if you don't have a rich amount of data, but you can, if you've got a whole portfolio and you have nothing more than monthly electricity consumption, then that in itself is useful. So that, I mean, that's only 12 readings a year per building, but if you've got a lot of buildings, so if you're like Commonwealth Bank, for example, and you've got 1,500 bank branches, that allows you to actually run some pretty good analytics against, square meters and revenue numbers, and straight away you can start to see a pattern of outliers. So there's no Goldilocks perfect amount of data. If you're looking at a single building, then you really want to dig in and get some rich data. So typically on a single building, we'll try and access at the barest minimum either BMS data or 15-minute sub-metering data. But yeah, there's no perfect answer to that.
And definitely it's a scalable platform. So in the case of the 3 CSIRO buildings that are being ingested into both the Switch platform and the Synapse platform, there's over 15,000 data points there. Yep. I'm not sure whether they're measuring every 15 minutes or every 30 minutes, but it's...
and they're running 3 different BMS. So in that case, that's where wherever you start to do what I call data wrangling, that's where the value of the platform comes in. So it's as soon as you're starting to have to ingest data into spreadsheets and keep spreadsheets up to date, then you've already got a problem that the data clearinghouse can start to add some value for you. So in the case of the 3 CSIRO campuses, yes, those were 3 different BMS, and to be able to do comparisons across those 3 campuses, you would be forced to extract the data from the BMS, put it into spreadsheets, and then start to run that very manual process of doing those comparisons.
And then you've got a particular building and what you get out of a particular building, and then it's the kind of what can you do when you've got a fleet of buildings at a sort of system level. So one of the projects that we expect to come on stream there in this sort of retirement living, that's actually getting down to household level data. And so, that's not particularly rich in inverted commas data. Yes, it's got thermal comfort stuff, but it's also got status of the air conditioner there. But I guess the ability of the data clearinghouse then to aggregate that from 500 different air conditioners then allows you to be operating at a system level to minimize the peak demand of the network as opposed to peak demand of an individual building.
And as people start to add IoT sensors for indoor air quality, and we're seeing a lot of that post-COVID, then you're even on a single building, you've got that problem where you've got several different systems. Now you're adding these IoT sensors, and none of that data is accumulated in the same place, and so you're not able to do analytics across your whole data set.
Yep. As a question, I was almost going to ask it myself, which is around, well, how much data is too much data there, and at what point, I guess, are you sort of paying a lot for cloud hosting on Azure or AWS or whatever the?
There's no such thing as too much data. Like even if you're not using it today, the hosting it's nothing. Where the fees start to escalate in cloud hosting is in the compute time and in the throughput. So, if somebody's running huge reports, for example, across big data sets, then that's where it gets costly. But if all you're doing is ingesting the data and storing it for a later use that you might not even be able to know what that is today, there's almost no cost in that.
Yeah, cool. This question, any specific algorithm or method to determine a range of suitable sizes of renewable investment for a building? The platform is designed as an operational platform. That is, the building has been built, the PV is on the building, etc., and so you're operating the thing in real time and charging, discharging, flexing your load, etc. So it's not so much there as a sizing tool in the way that Homer would, for example. Many of you would be aware of the Homer package, but it does actually raise the kind of concept. Well, with these standard ontologies and things, can we take at least the building fabric sort of data out of the BIM models and sort of port that across and pre-populate our data models and things. And so I think there's work to do, and I'm the operating agent for IEA Annex 81, data-driven smart buildings, and I know that's one of the questions they're thinking about is, do you have lots of these schemas all operating in their own little siloed place of ecosystem, or do you try and get a sort of end-to-end one standard to rule them all type approach? So I think that one's a work in progress, and that sort of segues into another question here. Were you able to leverage haystack or brick schema for tagging? Yes. So the Synapse version of Data Clearinghouse that we've been looking has very much been utilising brick as the schema, and haystack tagging is something that we would certainly take advantage of. In the International Energy Agency work, in fact, we're looking at running a competition in the next year or so, which actually it sort of looks at natural language processing and machine learning and sort of techniques for taking random data labels that might be given by a system integrator out in the field kind of thing, and actually recognizing what that is and automatically creating a brick schema model there. So yeah, again, that's an area that is continuing to develop, and we're not looking to reinvent any standards. We'd use existing standards. Thanks for those questions. Just Mark Goldsworthy, that plot you had, the root mean square error, that was the x-axis there. If I saw that right, that was up around sort of 30% root mean square error. That sounded like a large number. What's the issue there that none of the models could do better on that?
So that was the root mean square error on the unseen data set, not on the data set that the models were trained on. So typically the number that, say, ASHRAE or someone puts out as the minimum error that you need to have a good model, that error is based on the training data, not the analysis data. So when you actually look at the data for some of those buildings they had up there, they really had some very unusual behavior. So you might see, over a few particular months, the energy use just dropped to almost zero for no apparent reason, and so that if you were going to do, we really had no insight as to why these things occur. So when you do M&V in the field, you would know, that perhaps the site was operated differently over a certain period, and so you wouldn't use that as your training period for the model. So it was really quite a difficult data set.
It sounds like in terms of actually the EVO organisation in capturing their data, they didn't do any special smoothing to make this the ideal data set. They just dumped data out there and said, find the best that you can do with this kind of stuff. Yeah, interesting. Yeah,
and really, what it's doing is predicting energy an entire year in advance. So you don't know anything about the building other than the last year of its energy use, and you need to say somehow what the energy use will be at 1 hour of the day, 7 months from now, 8 months from now. That's a difficult problem.
Mm.
Yeah, so look, we might wrap things up there. So look, thank you everyone for registering and attending today's webinar. And a thank you also goes out to the project lead partners, participants, and all the presenters for today's webinar. Today's webinar is the second of the iHub webinar series, and we would love to see you again tomorrow at our final session on Living Labs, which is going to be held at the same time of 12:30 p.m. Australian Eastern Daylight Time. For more information regarding the Innovation Hub and to register for tomorrow's webinar, please visit the website that's up on your screen, so ihub.org.au, and we look forward to seeing you all again shortly. So thank you once again, everyone, and see you soon. Bye-bye.
Thanks, Bree. Thanks, Deb. Thanks, Mark.
Bye.